Hello everyone, welcome back to Spectrum classes. In this video, we are going to discuss about the oscillatory motion. So, before discuss about the oscillatory motion, we must discuss about the different type of motion because oscillations are a special kind of motions, right? So here I have summarized few different type of motions. One is rectilinear motion, another is projectile motion and periodic motion. Here and the oscillatory motion. So the examples are given here in the pictorial form. So rectilinear motion is the motion on a straight path, right? So here the example, a car is moving on a straight road. So this is called a rectilinear motion. Now the second is projectile motion. When an object obeys or follows a curved path, that is called projectile motion, right? And here this is a periodic motion. So I have taken the example of earth is revolving around the sun. So this is called periodic motion. And oscillatory motion is the sub part of this periodic motion. Here is the condition that the object is moving to and fro or back and forth about its mean position or an equilibrium point. So here the difference between these different kind of examples is that the rectilinear and projectile motions are non-repetitive motions because they do not repeat themselves after certain interval of time. However, the periodic motions repeat themselves after a certain interval of time. But the oscillatory motion has a certain condition that it is bounded and it's a to and fro motion or back and forth motion about its mean position, but it repeats itself in a certain interval of time. So here I have summarized few more examples of periodic motion. This earth is revolving about the sun and here rotation of the earth. Here arms of the clock are moving, are following periodic motion in this clock, and this boy is playing with the football and he is just pushing it to and fro, right? Now the next example is, which is very important, the person is moving up and down on the step of the stairs, right? So these are few examples of periodic motions. So here I have summarized what is called periodic motion. So periodic motion of a body is the motion which repeats identically after a fixed interval of time. The fixed interval of time after which the motion is repeat is called period of motion, right? All periodic motions may not be oscillatory because the basic concept of oscillatory motion, here I have underlined this, oscillatory motion is to and fro or back and forth motion about some mean position. So in these objects, the objects are not moving about the mean position. I am just going to discuss it in detail in the next slide. However, all oscillatory motions are periodic motions, which is important because each oscillatory motion is completed in a definite interval of time or it repeats itself after a definite interval of time. Now we are taking the last two examples. Here is this boy which is playing with the ball. Now the position of the ball is towards its hand, and say at that moment the position is located over here on a vertical line. So this is the position of the ball initially. Now he pushed the ball towards the ground. So while this ball is touching the ground, the position of the ball is here. You can say it should be here, but because it is the time scale and this is the distance scale, so after some time it is touching the ground, not at the same instant, right? That is why it is somewhere towards the x-axis or time, right? Now the second position is this and third position is this. And now if we are just joining these lines, so here is the pattern for this kind of motion. However, the condition for the oscillatory motion is that it is moving about its mean position. So some mean position must be there. So here you can see no mean position is there. The second example, which is the step up and step down, right? So this kind of motion can be drawn in this manner. So this is not, again, this is periodic motion. It repeats itself after certain interval of time, but it's not a vibratory or oscillatory motion, right? So here these are very interesting examples in my opinion. So I thought I should summarize here. Now examples of oscillatory motion. So here I have summarized few examples of oscillatory motion. Say the pendulum of this clock. So this is moving this side and this side, right? I can draw this also. So here the motion of this pendulum. This pendulum is moving about its mean position, going this side, then coming to this side, moving to this side again, and then coming back to this. So here is the mean position for this pendulum of the clock. So this is called, this can also be shown like this. So here is the mean position and it is moving to and fro. So this is called oscillatory motion. Second example is spring. So this spring is moving, say this is the mean position, this is the extended position, and here is the compressed position. So it is moving like this, right? So this is again oscillatory motion. Here you can understand in a better manner with this example. So this is the example. Here is the mean position. This is moving here, then going back, then going to this side, and then coming back to this mean position. So here I have represented the equilibrium position, and this is the trajectory which is shown over here, this dotted lines, and here this is the theta angle which this pendulum forms with the pivot, right? I will discuss it in next upcoming slides why this theta is important in this case, why length is important in this case, and why the what will be the displacement in this case. So we are going to discuss in the next slide, right? Now we are just going to summarize the oscillatory motion, what is called oscillatory or vibratory motion. So what we have seen out of these three examples is that vibratory or oscillatory motion is that in which a body moves to and fro or back and forth repeatedly about a fixed point. That fixed point is called its equilibrium position or mean position, right? And this repetition will be done after a certain interval of time. So this is very important, that certain interval of time. Then the next point is that in such motions the body is confined within the well-defined limits. So this is again a very important point, and this we are going to discuss during the simple harmonic motion, right? So this is called extreme positions of the boundary conditions on either side of the mean position. So two conditions are there now, periodic as well as bounded motion. So these two are very, very important points. Periodic and bounded motion here is of a body about a fixed point is called oscillatory or vibratory motion. So this is the complete definition of this, right? Oscillations, right? Now we are coming to the harmonic oscillation. So here I have just drawn, so this is not up to the mark, but just exemplary way we can consider this. So this motion I have drawn here. Say if it is here at equilibrium and it is moving towards the left side and then it is going to up and down. So here is the mean position. Its mean position is this, right? So it is moving towards the y-axis plus and y-axis minus. So this is called, and this is 0, or we can say mean position. So this is our oscillatory motion which is represented pictorially in this manner, right? Now coming to the harmonic functions and harmonic motion, because oscillatory motion or oscillations are also known as simple harmonic motion. So how this simple harmonic motion term introduced over there, so that is again very important, and to understand that term we first understand what is called harmonic functions. So this kind of function in mathematics or trigonometry we can just define by the sine or cosine functions. So these sine and cosine functions are simple, periodic as well as bounded. How we can say these are periodic and bounded, that I am just going to discuss here. But before that I am just going to summarize this. So these functions have a period of 2 pi radians, right? And this is called harmonic function. So here I am just going to summarize that sine theta. For the sine theta we are starting with, if about this point, say if about this point we are having this circle, so this is the angle of, this is started with 0 and this is ended with 360, right? 360 degree, this is 0 degree. So 0 to 2 pi, right? So it is 0 to 2 pi. So if we are having this 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. So here if we divide this, so 0, pi by 2, pi, 3 pi by 2 and 2 pi, and we are having the values for the sine theta is 0, 1, 0, minus 1, 0. So here you can see this is in plus direction, this is in minus direction, and this is the 0 mean position. And similarly if we repeat the cycle again and again, we will get the same numbers repeated themselves after one cycle, right? So if I am just going to show you, this is 0, this is 3 pi by 2 here, this is again, this is pi, say 2 pi, this is again pi or 0, this is pi by 2, and this is pi, this is 3 pi by 2, and this is 2 pi, right? So here you can see, so this is the sine and cosine functions are bounded as well as periodic. They repeat themselves. So here if we say think 0, so 0 to this 2 pi, it again and again repeats itself. So this is bounded as well as it is periodic. So the sine and cosine functions are bounded and periodic, and these are known as harmonic functions. Fine, but here in this case tan theta, tan theta is sin theta upon cos theta. So this term 1 upon 0, it is undefined, or sometimes it is written as infinitive, right? So this tan theta is not periodic because it do not repeat itself, right? So we are just considering only sin and cos. Now coming to the harmonic oscillation. So I have already discussed that harmonic oscillation. So here is the harmonic oscillation. Say this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, right? So here I have summarized this. Harmonic oscillations is the oscillation that can be expressed in terms of single harmonic function, sine and cosine functions, right? And these are shown over here. Harmonic oscillation of a constant amplitude and single frequency, this is again important, right? So these are called simple harmonic motions. So we started with the oscillations, and now we are just landed to the simple harmonic motion. So I hope you understand periodic motion, then oscillatory motion, then harmonic motion, and then simple harmonic motion if it is having constant amplitude and single frequency, right? So we are just coming to the simple harmonic motion here. Fine. So this is very important to understand the term.